In geometry, we can measure an angle, just like we can measure length in different units, like feet and inches, centimeters. We can measure angles with different units of measurement also. So the thing that we often measure angles with are degrees, and I think of a degree, it's like a little skinny, like pie slice, and I could fit so many degrees inside the angle. But there are other measures, just like feet and inches, things like that. So if my unit of measurement is like a bigger type of angle, well, there'll be fewer of those, but it still is talking about the same angle. In this lesson, we'll look at a unit of measurement that's not a degree, but it's called a radian. So here's a unit circle with a 30-degree angle in there. And the radian measure is basically what is the length of this arc. Well, the whole circle is 2 times pi times radius, which is 2 pi. And this 30 degrees, 30 over 360, is 1/12. So 1/12 of the circumference is pi over 6. And we say that 30 degrees in degrees is pi over 6 because 30 degrees in a unit circle intercepts an arc length of pi over 6. The official definition of a radian is, here's a radius, and if I make an arc length that's the same length as that radius, I have this thing which is, it's almost like an isosceles triangle, but it's not an isosceles triangle because this curvy portion is 1, so this line that goes across is going to be less than 1. If the line, that red line, was 1, this would be a 60-degree angle, but it's not, and we call this 1 radian. To convert from radians to degrees, we need some sort of thing that both, there's a number of radians that measure the same thing as the measure of degrees. So we're going to use 360 degrees, which is an entire circle. But how many radians are there in a circle? Well, if this is 1, and then here's like a second radian, and a third radian, and a fourth radian, and a fifth radian, and a sixth radian, we get a little more than 6 radians fill up the circle. Well, how much exactly? Well, this is just 6, but the circumference of a circle is 2 pi, which is about 6.28. So this last piece is, these are all 1 radian angles, and this last piece is 0.28. So we can say 360 degrees is equal to 2 pi radians. And if you divide both sides by 2 pi, you get 1 radian is equal to 360 over 2 pi degrees, which can be turned into 180 over pi, which is around 57.2 degrees. And that's how you convert. So 1 radian is equal to 180 over pi degrees. And if we know this, we can convert degrees to radians pretty easily. So if I have 180, well, the first one is 360 degrees, is obviously 2 pi radians. And half of that, 180 degrees, is going to be just pi radians. That's literally pi. 3.14 of those 57-degree angles add up to 180 degrees, and 90, which is half of that, is going to be pi over 2 radians. And 60, which is a third of 180, is going to be pi over 3 radians. And 30, which is half of 60, is going to be pi over 4 radians. And 30 is pi over 6. And 45, which is half of 90, pi over 4 radians. So those are our basic ones, like multiples of 45 and 60 we can do that way. If I see something like this, it's 2 times 60 degrees, so it's 2 times pi over 3 radians, which is 2 pi over 3. Or something like 135, if you notice, it's 3 times 45, so it's 3 times pi over 4, which is 3 pi over 4. Or 150, it's not a multiple of 60, but it's a multiple of 30. It's 5 times 30, which is 5 times pi over 6, which is 5 pi over 6. But maybe you get some angle that's not so familiar, like 72 degrees or something like that. So to turn from degrees to radians, you could multiply by 180 over pi. Whoops. I mean pi over 180. So we get 72 pi over 180. The degrees kind of like cancel each other out. And then we can reduce that, divide both by 9, get 8 pi over 20, and then divide both sides by 4 and get 2 pi. So to summarize, degrees times pi over 180, degrees times pi over 180 is equal to radians. It also goes the other way. Radians times 180 over pi can equal degrees. Some radian measures, like if you know the basic ones, and then I say like 4 pi over 3, you might say, well, that's 4 times pi over 3, and I think of pi as 180, so it's 4 times 60 equals 240. You don't need this conversion then. But if you get something like 2 pi over 5, if you multiply by 180 over pi, the pi's kind of cancel out, and the 5 maybe cancels out with the 180, get 36. So the main thing from today's lesson is these are your conversions from degrees to radians and radians to degrees. Now on graph paper, if I'm using radians for trigonometry graphs, this is pi, it's somewhere between 3 and 4, and 2 pi is between 6 and 7, and this is 1 unit. So if I make pi over 2, that's kind of like 90 degrees, and 3 pi over 2 is like, well, it is 270 degrees. And if I have to do y equals sine of 2x, I can graph it. There I have my starting point. But my period is now 2 pi over the b value, which is pi. So that means this curve ends here at pi, and halfway through I'm at 0 also, high point, low point. So we can do graphs if we're thinking of the angle in radians instead of degrees. Our graph paper now can use units 1, 2, 3, 4, 5, 6, or pi's between 3 and 4 and things like that. We don't have to make really distorted graph paper anymore. We can go in the opposite direction. Here I have a graph. I have some kind of something like this. And this point is pi over 3. This is more like it. This is pi over 3 comma 0. This is 4 pi over 3 comma 0. So what I see here, and this point down here is that the y value is -2. So what I see is the amplitude is 1. It's a cosine graph because it's starting at its high point, ending at its high point. Since the difference between 4 pi over 3 and pi over 3 is just pi, I can say 2 pi over pi equals 2, and that's going to be my number here. And since the starting point is at pi over 3, to the right, we say x minus pi over 3. and the middle line is down here at -1. So we can go backwards also. If we're using radians, we can answer the same sorts of questions we could before, but we end up with sometimes pi's involved. Now that we have this idea of radians, sometimes we want to model a real-world situation. Maybe this is time, this is like feet, just different things. But here's a situation where the starting point of this upside-down cosine curve is 0, 1, and the ending point, or the starting point of the next cycle is 12, 1, and its maximum here is 11. Now this t is not degrees, it's not radians, it's time. But we can treat it like radians, because at least it's in the same kind of, radians are these bigger units, so it's close to being radians. So for these real-world situations, we often treat it like radians. Well, I can now create the equation. Here's the middle line. These are 10 apart, so it's -5, negative because it's starting from a slope point, cosine, bracket, there'll be some number over here, x minus 1 plus it's going to be plus 6 because I'm 5 above 1, so this is 6 here, that's 5, and then 5 more to get to 11. Now the number here, we look at the period from 0 to 12, so it's 12. So that means the b value, the coefficient here, if I'm thinking in terms of radians, is 2 pi over 12, which reduces to pi over 6. Pi over 6 is a little bigger than a half. Just we see that pi over 6, we sometimes forget it's just a number. But that's going to be the answer to this question. So this is like, this is 12 over here. So this is a bit of a stretched out cosine curve because its period is not like 2 pi, 6.28, but it's almost double that. Or it is, it's 12, which is pretty close to double. Okay, so you'll see these b values have pi's in them frequently, especially in real life situations. Actually, I have a slight mistake here. Would you get rid of this -1 because this thing is starting at 0 is the starting point. So it's not shifted over. Sorry about that.